Okay, all the problems that are solved here are solutions to the question in the recommended book Operations Research, an introduction, 8th edition by Hamdy Taha. This is the book. I'm sure you have read the book before you started attempting these problems, and ideally you should have read about the two variable LP model and seen an example, and also know a bit about properties of the LP model, stuff about proportionality, additivity, certainty, etc. So let's go straight to the problem. We are going to problem set 2.1a, which is on page 12 of the book Operations Research and Introduction by Hamdy Taha. So for the ready mix model, construct each of the following constraints and express it with a linear left hand side and constant right hand side. There are 4 parts to this question. Before we go to that, a quick revision of the actual ready mix company problem. This would be 2.1.1, and in page 9 of your book, I'm sure you have seen this solved example where you had the ready mix company, and where they produce both interior and exterior paints from 2 raw material M1 and M2, and tons of raw material per tons of exterior paint, interior paint, and maximum daily. And the particular example was they tried to solve, and they want to determine the optimum product mix of interior and exterior paints that maximizes the total daily profit. Alright, so just keep these numbers at the back of your mind. Let's come back to the problem set. For the same model, construct each of the following constraints and express it with a linear left hand side and a constant right hand side. The daily demand for interior paint exceeds that of the exterior paint by at least 1 ton. That is, the interior paint exceeds the exterior paint by at least 1 ton, right? So this we can represent it by an equation x2 minus x1 greater than 1, or minus x1 plus x2 greater than 1. So we have a linear equation at the left hand side and a constant at the right hand side. Part B, daily usage of raw materials M2 in tons is at most 6 and at least 3. So we have x1 plus 2x2 greater than or equal to 3 tons, right? It needs to be at least 3 tons, and x1 plus 2x2 should be less than or equal to 6 tons. Part C, the demand for interior paint cannot be less than the demand for exterior paint. Or we have x2 greater than x1, or x1 minus x2 less than or equal to 0. Finally, the last part, the minimum quantity that should be produced of both the interior and exterior paint is 3 tons. We can represent it by an equation x1 plus x2 greater than or equal to 3. Good. A simple warm-up. Let's go on to the next problems, and you can see them getting tougher as we go down.